The Part 1 video showed how the QE for motor, which works in conjunction with the Renesa's motor workbench RMW, can be used to easily perform parameter tuning. This Part 2 video will show how to design and adjust the parameters and how to evaluate motor control using the RMW analyzer function by writing program with tuned parameters to the RL78 G24. After the measurement of the characteristic parameters of the motor performed by the tuner function launched from the QE for motor is completed, the output window will be displayed. The Tune Result tab displays the measurement results. The Mode tab allows you to select the control method of the motor. The Inverter tab displays the characteristic parameters of the inverter board, and the Motor tab displays the characteristic parameters of the motor. The Control tab and Adjust tab display the automatically designed control parameters based on the measurement results. Scaling to the PU system and Q format number used in the sample program are also automatically designed. The parameters displayed in blue frames can be rewritten manually. The designed and adjusted parameters are reflected when Parameter Set is clicked. Once the parameters have been verified and adjusted, it is possible to perform a simple evaluation of the motor drive by running of a drive test. Startup, steady state drive, step response for speed and current can be performed. Click Edit to change the driving sequence for each test. Check the test items and click Run to execute the selected drive test, and the waveform is displayed in the Scope window. The Start tab displays the waveform and the responsiveness to the reference during startup. The Steady State tab displays the waveform and the stability during steady state driving. The Step Response tab displays the waveform and the characteristics of the step response. Click Report to view a list of the tuning and drive test results. Click Output to output this list as a PDF file. In the Output window, click Output Header File to reflect the tuned parameters as the header files of the sample program. The header files containing the tuned parameters are located in the config folder of the sample program. In the QE for motor workflow, click Build Program to build the project. Click Download Program to write the built program to the RL78 G24 on the inverter board. Click Launch Renesa's Motor Workbench Analyzer to start the RMW Analyzer function. The Analyzer function can perform a detailed evaluation of the motor drive. The control window allows reading and writing of variables registered in the microcontroller's internal RAM dynamically even while the motor is driving. The User button allows you to customize the sequence of reading and writing of registered variables. By default, sequences for start-stop of drive, setting reference speed, and selecting rotation direction are registered. The sequence can be executed by clicking the button. The Scope window displays the internal variables of the microcontroller as waveforms with an oscilloscope-like operation. Click the Run button on the Scope window, set the reference speed in the speed reference of the User button, and then click the Run Stop button on the User button to start driving the motor. The waveforms from startup to steady state are displayed. Here, the estimated speed relative to the reference speed, D-axis current, Q-axis current, U-phase current, and rotor phase error are displayed. Press the Run Stop once more to stop the motor. Now change the parameters and confirm the change of the startup waveform. If you increase the value of the acceleration in the control window and remeasure the startup waveform, you can see the acceleration has become larger than before. In this way, you can evaluate the motor driving operation by rewriting the internal variables of the microcontroller. As introduced, by using the RL78 G24 Motor Control Evaluation Kit, the sample program for sensorless vector control, and the motor control development support tools, such as the QE for Motor and Renesas Motor Workbench, RMW, provided by Renesas, it is possible to drive motor and evaluate motor control quickly and easily. For details, please refer to the Renesas website.